Well, good morning, and thank you for being here. I want to start by acknowledging that there is a significant Japanese community here in southeast Michigan, and although all of us have our eyes on developments in Japan in the wake of the disastrous earthquake, our Japanese colleagues have close ties to personal friends and family, and so our hearts go out to them and our prayers go out to them. We, along with the entire world nuclear community, are closely monitoring events in Japan. I want to be clear that we're not here this morning to speculate on those events. It's important that news on nuclear developments come from the Japanese nuclear industry and from the Japanese government. That said, we have begun to receive questions in the wake of the events in Japan about whether there are things that Michigan citizens should be concerned about, and that's what I want to address today. Japan is dealing with a natural disaster of immense proportions. An earthquake that registered 9.0 on the Richter scale, followed by an intense tsunami. That raises the question, what natural disasters might our Fermi 2 power plant face, and is our power plant designed to deal with them? The most frequent, highly destructive natural occurrences that we face here in the Midwest are tornadoes. Fermi 2 was very specifically designed with hardened systems aimed at dealing with tornadoes. And as it turns out, the Fermi 2 plant took a direct strike from an intense tornado this past year in June. You may recall the tornadoes that swept through Dundee and many of the communities downriver, including where our Monroe power plant and our Fermi power plant are. The plant shut down in a safe, orderly fashion. It did take a direct strike at the nuclear plant itself, shut down in a safe and orderly way. All the safety systems functioned as designed. The tornado did remove some of the siding and some roofing at the plant, but beyond that had little impact, and the plant started up a number of days later. So we have had a recent test of the plant's safety systems with respect to the most frequent natural disaster experienced in the Midwest, and that experience confirmed the ability of the plant to deal with those events in a safe manner. With respect to seismic activity, I'd like to start by saying that Michigan's geology and exposure to intense seismic activity is very different than those in Japan. That said, more moderate seismic activity does occur in the Midwest, and the plant design does address the possibility of an earthquake. The intensity of the earthquake that we're designed for anticipates an energy level that's more than 10 times higher than anything seen in Michigan since the 1800s. Now, with respect to water and flooding, and in reality, the issues that are being dealt with in Japan are more a result of the flooding from the tsunami than from the earthquake itself. Lake Erie would not generate a tsunami of the sort witnessed in Japan. However, the plant is very specifically designed to deal with waves and lake surges, which do occur. It has seawalls that are specifically designed to address those. In addition, crucial safety systems at the plant, specifically our backup generators and the electrical switchgear, are elevated and specifically designed to deal with flood conditions. In addition to all of this, I think it's important to recognize that there are key differences between our Fermi 2 plant and the damaged units in Japan. Fermi is a later stage design than those units, and that design incorporated a host of safety systems and safety system design modifications that are not deployed in the Japanese reactors. Now, with me today is Jack Davis, our Chief Nuclear Officer, and I'm going to let Jack review some of those key design differences that we have available at our plant. Jack?
Thank you, Gerry. I wanted to talk in three specific areas where our design or by subsequent modification is different than the Japanese, and these are the areas where they seem to be having the most difficulty. The first is power. If in fact their backup emergency diesels were functioning, we would not be having this press conference. They would have the reactor shut down and shut down safely. At Fermi, our diesels are in fact in concrete bunkers above the design floodplain, and all the equipment necessary to provide power to the plant is protected against natural disaster. Additionally, as Gerry mentioned, we have switchgear that is well elevated above any floodplain, again, inside of reinforced rooms where we would be able to hook up diesels that would be brought in by trailer if absolutely necessary. And there's a third backup, which are combustion turbines powered by diesel fuel, which are also on the site. So we have a number of backup power supplies that are available to us to run our safety systems. Another area where the Japanese are having some difficulty is being able to vent their primary containment. By design, we in fact have vents, and in fact 2 vents that are very sturdy structurally. They're what they call hardened, to be able to deal with any kind of environmental event and allow us to vent both the torus and the primary containment. So those are different from the Japanese construction. Beyond that, over the years, we have continued to develop procedures and equipment that allow us to cope with a loss of power. And I would just note, as you know, we have applied for a license for a new reactor at the Fermi site. The new design, in fact, uses all passive safety systems to cool both the core and the containment. Therefore, it would require no power. So that is an enhancement with the next generation of nuclear plants. Gerry?
Well, thank you, Jack. I am going to wrap up and then we'll open up for questions. So nuclear power is a critical energy source in many parts of the world. It supplies 20% of our electricity here in the United States. It is the dominant source of electricity in our neighbor, Canada. It supplies 70 to 80% of the electricity in France. It's heavily used in Scandinavia. It's a key source of electricity in Korea, Taiwan, Russia. It's a growing source of power in China and India. Given this, what's essential is that we and other operators of nuclear plants in the United States and around the world remain intensely committed to the safe operation of these plants. We have over 100 nuclear units in the U.S. that have operated for the past 30 to 40 years, depending on when they were first built. And they have a safety record that is very strong. One other thing I can assure you is that the worldwide nuclear community uses every serious incident to advance its safety practices and to learn. And I can tell you that that's already underway around the world today. I'll now open up the floor for questions. So I think there is an intense emotional response at a time like this, especially when you're witnessing these events in Japan. I would encourage the public to step back and take stock of our actual record here in the United States. 40 years, we've never had an event that had any public health impact or any significant environmental impact. The closest was 3 Mile Island. In fact, that event was contained. Everything that happened was within containment, no material release of radiation. There's never been any other event that approached that here in our country. So, been an important source of electricity with no impact to public safety. The NRC and the Institute of Nuclear Power Operations are keenly focused on making sure that that remains the case, as are we as a plant operator. We take that as our first and highest duty to the public. I can tell you that there will be numerous lessons learned that come from this that plants around the world will incorporate. One thing I would say is that these were early stage designs, and many safety system upgrades occurred in later stage designs. Jack mentioned some of those. The critical things they've been dealing with in Japan are loss of backup power to run the cooling systems. The loss of the power really was caused by the tsunami surge, which drug away the fuel tanks. Jack mentioned that our backup generators are in hardened structures. That would not have happened here. If we had a tsunami, which is highly, highly unlikely, wouldn't have happened here, and we'd have an entirely different outcome. The other thing they're experiencing in Japan is these hydrogen explosions. One of the safety modifications made in later plants is venting, hardened vents to make sure that, actually we have numerous vents that assure you can get the hydrogen out and vented to the atmosphere so that those explosions wouldn't be an issue. So those are two examples. Third is the switchgear. They tried to bring in portable power, but their switchgear was flooded. Our switchgear is multiple floors off the ground, would have been easy to attach backup power to. I think what we need to do is step away now from this experience, learn from it, and then take stock of the fact that the experience of the nuclear industry worldwide has actually been one of extremely high levels of safety. I do think, though, that if you're saying, will it produce some slowdown or some pause in the evaluation, I think that's true and inevitable. Well, we saw about as intense a tornado as we've ever experienced come through. If you saw the destruction this past year in Dundee and the downriver communities, it was intense. And that tornado hit our nuclear unit head on. It actually hit the generation structure itself directly. So it wasn't nearby, it was right on it. And we came away from that experience with minimal damage. We had some siding removed, some roofing removed. The plant automatically shut down as it was planned. The backup systems worked, were fully functional, and as I said, we started up a number of days later. So this is an interesting question. Is the make or model the same? About a third of the reactors worldwide are GE designs, General Electric. And so ours is a General Electric design. Westinghouse was the other big manufacturer of nuclear plants. So yes, it is a GE design, but there were many evolutions of the GE design. Ours is a later stage evolution. This plant is an earlier stage evolution of the GE plant design. Backup generators, if you went down to Monroe, you'd see they're in a hardened concrete bunker that's elevated well above any flood we could anticipate at the site. And the switchgear, which is where you would attach portable power, are multiple stories off the ground. So both of those, which are key portions of your backup, are far out of the reach of any flood that we could anticipate. Concerning the new power plant, as Jack mentioned, one of the advanced features of the new power plant is passive safety systems, which means you don't need electricity for the safety systems to work. In terms of commitment to it, we're going to see our way through the licensing process, and then we'll see where the environment stands, both in terms of need for power, environmental regulations, and what we learned from this event.